This video was created by Danny Kessler, Associate Professor and Korea's first PhD in wellness tourism. We often look at people who live past 100 and assume they won the genetic lottery. But assuming long life is simply an inherited biological advantage is statistically incorrect. This data visualization breaks down the actual structural split of longevity control. Inherited genetic markers dictate only 10 to 20% of your lifelong health trajectory. The remaining 80 to 90% is dictated entirely by epigenetic variables. Because your DNA controls such a minor fraction of your aging outcome, your lifespan is not hard-coded at birth. It operates as a highly programmable biological output. Your static DNA is the unchangeable biological hardware. Epigenetics operates as dynamic software streams that continuously program that hardware. Institutional wellness regimens heavily prioritize optimizing this physical hardware, relying on high-concentration supplementation and intense, physically isolating conditioning routines. But focusing entirely on the physical substrate neglects the essential software programming required to actually direct how you age. Attempting to optimize human longevity without those epigenetic inputs yields a structurally deficient strategy. It routinely fails to halt cellular aging. The first pillar of effective epigenetic modification requires an aggressively controlled physical environment. This means actively eliminating exposure to modern environmental toxins. It requires drastically reducing proximity to industrial microplastics, processed additives, and synthetic agricultural chemicals. Combining this clean physical environment with highly concentrated nutritional protocols triggers a specific biological process known as cellular autophagy. Autophagy acts as the body's internal clearance mechanism. It dissolves and clears away damaged cellular matter, actively mitigating early metabolic decline. A pristine environment and optimal cellular clearance are mandatory, but they only establish your baseline physical defense. On their own, they are entirely insufficient. The critical missing software component requires multidimensional intergenerational social integration. Remaining densely integrated into the daily economic and social fabric functions as an active epigenetic shield against aging. This graph maps neurological biomarkers against social behavior. It shows a clear inverse correlation. Tactile engagement and complex community play actively downregulate the production of cortisol. Dropping cortisol directly decreases systemic inflammation. By halting that inflammation, you halt the primary driver of cellular degradation. Objective real age metrics prove that maintaining a structured sense of purpose, often recognized as ikigai, operates as a primary modifier of biological aging. Chronic physical isolation degrades cellular architecture at a rate perfectly comparable to severe physical inactivity. The social matrix is an absolute biological necessity. Accepting this epigenetic reality requires a shift in behavior. You have to transition from a passive patient into an active operator of your own complex biological machinery. This timeline illustrates traditional medical travel, relying on reactive, acute treatments that happen only after catastrophic biological failure. Medical wellness tourism structurally reverses this. It prioritizes transit to elite intervention points in a closed-loop preventative system long before failure occurs. These elite destinations utilize continuous metabolic monitoring, sophisticated risk assessment, and objective sleep tracking to build a precise biological profile. But clinical data alone is meaningless. The true value lies in equipping individuals with the precise biological tools and autonomic stress reduction protocols required to sustain long-term behavioral changes. Maximum health span is not a geographic anomaly found in isolated zones. It is a scalable, measurable science of living well through proactive epigenetic control. This video was created by Danny Kessler, Associate Professor and Korea's first PhD in wellness tourism.